guys. Today we're going to go through theoretical and percent yield. So I think this is my fourth video of the day. I don't wear the same clothes every day. I'm just shooting them all on the same day. For some reason, it's important for me that you know that. So we've got theoretical and percent yield here. So when we talk about yields, theoretical, people kind of aren't familiar with this language very well. Theoretical and percent yields, when we talk about that, then we're talking about experimental data. So we're looking at this and we're saying, okay, in real life, let's use these mole ratios and all the stoichiometry that we've been doing, and let's talk about it, how it would affect real scientists, real people doing research. So theoretical yield, this would be in theory, you know, we say that, like for me, I'd say in theory, you are all watching these videos and understanding everything and everyone will get 100%. That's in theory. In reality, in actuality, is that gonna happen? Probably not. I would love it if that was true though. So when talking about mole ratios and yields, the theoretical yield is how much you should get of a product. So how much product you should get based on our balanced equation. So based on our mole ratios, how much product would you expect to get? Now, all of the calculations, all of the stoichiometry that we've done so far, those have all been theoretical. They're not in real life. They're based simply on a mole ratio. We're looking at the coefficients, we're balancing, working through the mole, we're figuring stuff out. Those are all theoretical. Now, in real life, the actual yield is what you actually get in products, what you would experimentally get. There's no way to calculate this. You would have to run an experiment and do it. So for our purposes here, you're always going to be given this information. We would certainly be doing a lab about this. If you were here, you would run a lab, you would figure out what your actual yield was, what your theoretical, etc., etc. Hopefully, when you guys come back, if you come back, we'll get through that stuff. But, okay, taking a look at this. So theoretical yield, how much you should get, how much you think you should get, actual yield, what you actually get in real life in an experiment. So we're going to work through this problem here. So calculate the theoretical yield of H2SO3 if 3.6 grams of SO2 is placed in excess water. So we've got 3.6 grams of SO2. You've got excess water. So now you really know what that means because you learned the limiting stuff yesterday. So if I've got excess, that means water is not limiting. I don't need to worry about. So this is the only thing I need to worry about. Now, you're supposed to calculate the theoretical yield. Theoretical yield in real life, you know, it's not that useful to say, well, there's going to be 4.7 moles. You want to find the mass of it because that's what we deal with, right? So if you're asking to find the yield of something, solve for grams. So I want to find grams of H2SO3 based on the 3.6 grams of SO2. So what are you going to do? It's a grams to grams question. How many brackets? 3 brackets. So you're going to go ahead and solve that now. So grams of H2SO3 equals 3.6 grams of SO2. First step, change that into moles. Second step, mole ratio. To balance. I'll give you guys trouble for that. Oh, I think it is balanced already. Good, it's balanced already. I'm saved. So 1 to 1 here. Last bracket, you would convert that into grams of the H2SO3. So now I need to fill in my molecular masses, which come from the periodic table. So this is 64, and I get 82.12. over here. So I did that really quickly because hopefully that's easy for you now. I hope that you understand that. You've done lots of questions like that, grams to grams, 3 brackets. If it's not, I would definitely pause the video and try to work through it yourself, see if you can figure that out. All my units are going to cancel, so everything's good, and you get 4.6 grams of H2SO3. Now you're going to turn your page to the next thing here. Now, this is to calculate now the actual percent yield, or calculate the percent yield. I'm just going to write this down. Calculate the percent yield if 3.87 grams of product was isolated. Now, it says they're collected experimentally. Isolated is another way of writing that. That's why I wanted to use that. So you've seen that language. People sometimes get confused by that. So that's how much product you actually got. So you got 3.87 grams. Now, you expected 4.6 grams. So some of the product was lost. That would be normal. It would almost be impossible to have a 100% yield, because as we've known through our lab work, I know we've only done a few, but there's always sources of error. There's no perfectly designed experiment, right? There's always places where error can creep in. So we know that 3.87 grams of product was actually weighed, was massed, was collected, but we expected 4.6. So the percent yield is going to be equal to, and this would be like how you would find the percentage of a test. Percentage of a test would be like the grade you got over the grade that you expected, which would be the 100%, right? So it's the same thing. So you're going to take actual divided by theoretical, and it's a percentage, so we're going to multiply it by 100. So in this particular case, you're going to take 3.87 grams divided by the 4.6 grams, which is what you expected, multiply it by 100, and you get an answer of, what is that? I don't have it written down actually. So 3.87 divided by 4.6, then you're going to times it by 100, of course. You have to maintain your sig figs through this though. So 2 sig figs, you can't have more than 2 sig figs in your answer because of that very first 3.6 over there. So you're going to have 84% is the actual yield. And that's that. So you're going to, when asked to calculate the theoretical, it's what you've always done. And then for the percent yield, you just take the actual, which would have been given to you, and divide by the theoretical. So pretty straightforward. You can now do exercise 20, and the answers are in the key there. That is literally the last concept for the mole unit. It makes me really sad that we didn't get a chance to do the labs for this, but like I said, hopefully you'll come back and we'll get going on that. So now, over the spring break, I would like you to try exercise 21. You should all be nice and bored because you're socially isolating and not going out. Please do not go anywhere or go out. So exercise 20 is the theoretical and percent yield. 21 is the mole unit review. After spring break, I'm going to start teaching the gas unit. So unless something changes, unless there's announcements from the province, but we'll figure that out later, and I'll update you all on Schoology. But we'll start a new unit then after spring break, so please don't leave this. Get working on it. Okay, take care everyone. Stay inside, wash your hands. Bye-bye.